So we're going to start Chapter 8 today, multiplying and dividing rational expressions. A rational expression is the ratio of two functions, so they're fractions. Your work needs to be organized, and remember you can only cancel in multiplication, never in addition. Factor all polynomials that can be factored. If there is an addition or subtraction problem, it probably needs to be factored. If it's already multiplication, it's already in factors. So for example, the difference between number 1 and number 2, on your examples, number 1 is all multiplication, so you can just reduce that fraction. Number 2, you have some addition and subtraction going on, so you have to factor the same binomials. You know, that's what can reduce out. You can't factor, like, take the x from x minus 5 and the x from x squared minus 1 and factor that out. Okay? You have to have identical binomials. So looking at number 1, I know it's hard to see what the exponents are, so I'll write it up here and you guys can make it darker on your paper. 45m n to the 8th over 20 n to the 7th. Okay, so since it's all multiplication, I'm just going to factor out my common factors. 45 and 20 have a common factor of 5. So that'd be a 9 and a 4. There's not a factor for the m to reduce with, so that's just going to stay. N to the 8th over n to the 7th. You're going to subtract those exponents. You wind up with n to the first power. So that's going to stay in the numerator. 9mn over 4 would be your answer. Let's look at number 2. 2x times x minus 5 over x minus 5 times x squared minus 1. So this one is mostly factored. The only thing that's not factored is this difference of two squares. And I can go ahead and factor it all the way down. So that's x minus 1, x plus 1. That way I can look at everything and make sure that I have everything reduced that I can. So right now you just have this binomial x minus 5 that matches this binomial x minus 5. So those two are going to reduce out. Now this is a factor of 2. There's not a factor of 2 down here that I can reduce with. This is a factor of x. There's not a factor of x down here I can reduce with. Okay, these two need to have matching binomials in order to be reduced. So your answer is just going to be 2x over, and it's okay if you want to leave the denominator factored. You could write it factored, or you could write it as a difference of two squares. Either way. Okay, that would be your final answer. There's nothing else that you can do with that. Are there any questions? Okay, let's look at number 3. We're starting out with the really simple problems, you know, because when you get to your assignment, it's going to be harder, of course, but the process is the same. So you need to make sure that you're factoring and then look for the like factors, matching binomials. Okay, so number 3, that's z squared w minus z squared over z to the third minus z to the third w. Okay, so this one, see, I'm subtracting in the numerator and subtracting in the denominator, so you have to keep those values together. Okay, you have to factor things out that they have in common. The numerator, I have a z squared in common, so I can take z squared out, and I'm left with w minus 1. In the denominator, I can take a z to the third out, and I'm left with 1 minus w. Okay, so I have a z squared in the numerator, z to the third in the denominator, so those can reduce out, right? When you subtract the exponents, it's z to the negative 1, so the z is going to stay in the denominator. That's just going to be to the first power. And if you start doing this kind of thing where you're like just marking through stuff and replacing it with other things, you got to be really careful. That's where people start to get messed up because they don't always keep their work all that organized. Okay, so you need to be very neat and organized when you do this. Make sure that you don't accidentally skip something. Okay, so right now I have w minus 1 in the numerator, z times 1 minus w in the denominator. And the w minus 1 in the numerator is very similar to this 1 minus w in the denominator. Okay, so but they're not the same signs, right? The signs are backwards. So what we can do is we can factor out a negative from one of those binomials. It doesn't matter if it's the top one or the bottom one. I'm going to factor it out of the bottom one. So I'll make that a negative z w minus 1. So now my w is positive and the 1 is negative. And now these binomials match and I can reduce that out. So what's left in the numerator? 1. That's right. So I could write 1 over negative z. You could put the negative in the numerator, or you could put the negative just out in front of your fraction. Those are all the same thing. As long as you have the negative one time, it's all the same. Any questions? Okay, why don't we try number 4, and I'm going to let you guys do that one on your own, okay? It's really the same as number 1 because everything is being multiplied. There's no adding or subtracting going on at all. So you can just reduce out as long as you have something in the numerator and something in the denominator. That is the same. And that a is a to the third in the denominator. So I'm winding up with 3 over 4a squared. Okay, so notice we can reduce diagonally. Okay, it doesn't have to be just straight up and down. As long as you have something in a denominator that can factor with something in a numerator. Any questions? Okay, let's look at number 7. We'll go on down to something that's a little bit harder. I'm going to give myself more room for number 7, though. Now, number 7 is a division problem. So when you have a factor or a fraction divided by a fraction, how do you do that? What do you do with the second fraction? You flip it over and you change it to multiply, right? So I'm going to change this to multiply, and I'm going to flip that second fraction over. Let's go through and factor everything that we can factor. So the first numerator, there's a common factor of 6. I'm going to take that out. Let's just work with this first numerator. And then we'll move on. Okay, so now I have a trinomial. My leading coefficient is not a 1. So you guys remember how to factor those? Kind of? You take the leading coefficient times the constant. That's negative 2. And the sign does matter. Okay, 2 factors of negative 2, that will add to be a plus 1. What would that be? 2 and negative 1. So what I'm going to do now is I'm going to expand that middle term. I'm going to use plus 2p minus 1p minus 1. And now I can group and factor. That 6 is just going to stay out in front for right now. So I have a common factor of 2p for my first 2 factors. Common factor of negative 1. So all the signs are going to change inside that last parenthesis. My binomials match. I have both of them p plus 1, which is what I want. So now I can consolidate the 2p minus 1 and write p plus 1 just one time. Okay, so that's my numerator. Now this second fraction, the numerator, I can factor out a 2. So I have 2 times p plus 5. And the denominator has a common factor of 3. So I take a 3 out and I have 2p minus 1. So now I'm ready to reduce. Now I want to look at binomials that match as well as regular factors that match, like this 6 and the 3 can reduce, and I have 2 left here, and that's going to reduce down to 1. This 2 and the 4 can reduce, So that's going to be a 1, and this is going to be a 2. And then my 2's here can reduce. So all of those are completely reduced out. There's just a 1 left. 2p minus 1 and 2p minus 1, those can reduce. Same binomial. P plus 1, I have identical binomials there. And notice in this denominator, instead of writing p plus 1 squared, I went ahead and wrote it twice. You don't have to do that, but that's just the way I like to do it. So now all I have left is p plus 5 over p plus 1. And that's going to be your final answer. There's not anything else that you can do with that. Okay, I'm going to stop here and then record the rest next hour.